see. Yesterday was a super easy day, so if you were on an awesome field trip, we are jealous that you did not miss that part of a day. However, we did a checkpoint on graphing linear inequalities. So that means you did miss that checkpoint, so you do need to get it out of the basket. Out of yesterday was 920, so out of the 20 slot. In the 20 slot in the basket. Some people didn't finish their checkpoint, and that was their homework. Some people, I didn't get to see theirs until the end of class, or because I was struggling because I had all your checkpoints at once. And you don't know it yet, but you didn't pass. So when we finish today's notes, the first thing I want to handle is yesterday's checkpoint on graphing inequalities. Ma'am. Okay, if you need it, I put all my extras in the 920. Okay, so if you didn't pass it, we're going to have to fix it at the end of class. And if you didn't pass it, you were probably just in a hurry, and you divided by a negative and you didn't flip the sign because it happens to benefit us. Thank you. Okay, so Natalie, we're not on YouTube or anything. No, they're come for you. Okay, so yesterday was good. It was graphing linear inequalities. We felt pretty good about that. We have a test next week. We agreed it should be Tuesday. At worst, we push it to Wednesday, but I'm really hoping for Tuesday so we don't get further behind in life. So we did piecewise functions. We took a quiz. I haven't finished grading those. I pray to have them finished graded by tomorrow. You would like that too. I mean, at the worst, you get it Monday. And if that is the case, then I guess I should move the test to Wednesday. So I've got to get them done tonight now. That's my motivation. Got to get them done. Okay, so piecewise functions is a major part of our next test. It is. But another part is graphing linear inequalities, is what we discussed yesterday. And the last thing, the main topic we're going to discuss takes today and tomorrow. It involves parent functions. Parent function. And I don't know if you read through the learning target, but I don't like some of the wording. So we're going to be rebellious, and we're going to change one of those words because I just don't like it. I don't think it's correct. So we'll get to that in just a second. If you notice, you are going to have some homework tonight, so you're praying at your notes quickly. That way you can go ahead and get those homework pages out of the way. The homework is directly from the notes. I am going to check it, but probably, well, I would like to check it, but I probably will wait until Monday. Not that you shouldn't go ahead and do it. You should, because you don't want to have homework over the weekend. Remember about last weekend when you forgot to graph all those piecewise functions, and you forgot to turn it in on Monday, and you had to turn in late? Remember that? You don't want that to happen again. So we're doing graphing only today, so you're only going to have to do the graphing problems in your homework. Tomorrow we're going to do the other half, so tomorrow night's homework will be the other half. But if you already understand it, to be honest, we'll do all the things at once. Okay, I got like 5,000 phones. What is your deal? I need help with these problems. Hey, if you're bored, you can file the papers. Okay, I need help with these problems. Yes, Braxton, you want to help me with number 7? Your hand was up first. 16 square root of 3?
Yes.
Okay, so what numbers did you use then? What times what? Something times 3. What's 16 squared? You took a perfect squares test. What's 16 squared? Somebody, anybody?
4.
16 squared. Square root of 16 is 4. What's 16 squared? Thank you. Thank you, Preston. Hunter, why am I trying to do that to you today? My God, that was yesterday too. Hunter, table 6 and table 5 can have a point. It was 256 times 3 gets you 768. I don't disagree with that. That sounds right. And then 256 is actually a perfect square. The square root of 256 is 16. So the real answer is this, but I wanted to show out what actually was going on in your brain. Again, that's why you memorize these perfect squares, because they were supposed to make your life easier. Yeah, here we are. Okay, 576. Yes, Natalie, you've had your number. 24? Okay, so she remembers her perfect squares. And her group can have a point for that.
Because 24 squared would equal 506.
Yes, dear. So 24 times 24 is that. So I don't know what I was going to do. 24 squared. But yes, that is the correct answer. Okay, number 9. Perfect page. 9 square root of 6 was her final answer, which I assume means she had 81 times 6. Perfect. So she knew the square root of 81 is 9. So 9 square root of 6, that's perfect page. Your group can have a point. Now on to number 10, which when I first saw it, I wanted to do 8 times 100, and that's not the right thing to do. Okay, yes, Arturo.
20 and the square root of 2.
20 square root of 2, which means you did 400 times 2, because that's 800, and the square root of 400 is 20. So yes, that is perfect. Arturo's group can have a point. Number 11, yes, Eduardo. 7 square root of 2, that means you thought it was 49 times 2, which is how you got 98. So 7 square root of 2, because square root of 49 is 7. Perfect. That's beautiful. And then last one, yes, dear, I know you try to answer everyone I keep skipping you, so you can answer last one. Okay, let's see. So it is 16 times 2, which is 4 square root of 2. Perfect. Again, remember that perfect squares test from forever ago? You weren't supposed to forget those. That way they can make your life a little easier when it comes to reducing radicals. I'm going to lay off that. Okay, you know 13 and 14 are going to be tomorrow's problem, so if you're trying to get ahead, you could do 13 and 14. 14 looks a little hard, but I swear you can do it. You just want to rewrite that last equation into y equals mx plus b. Y equals mx plus b. I swear you can do it. You're that good. Okay, today in our notes, we're not going out of order. We're going to page 27, which is the third page inside the packet. The third page inside the packet. Okay, I'm in a hurry like you, so we're going to skip some of the things. A blank describes one or more characteristics. We're going to cross out that first sentence and let that one go. The first blank we're going to go to is the next one, and it is the word parent. The parent function. The parent function is the simplest of the graphs in a family. And you're like, what kind of family? The linear function family, maybe the quadratic function family. In fact, on a math workshop 2 weeks ago, we had a list of like 6 different parent functions we discussed. Square root function, their family, all the different graphs you've talked about in life make up a family. Okay. So today, the other day in our math workshop, we talked about 6 different parent functions. And if you were in pre-calculus and you got to a section, because pre-calculus kind of starts off the same way. So if you survive algebra 2 with trig, then you can probably survive pre-cal. Pre-calculus kind of starts off the same way. But instead of just talking about 3 parent functions, they talk about a crap ton of them. I mean, like, I think 9, 10 maybe. There are a lot of parent functions. And that's not even an extensive list. There are a ton more than that. However, you and I are only going to focus on 3 today and tomorrow and on our next test. And these 3, you've seen 2 of them a lot lately. And a whole lot lately. The first one is a constant function. So, a straight line. Now, as we discussed yesterday, if it was y equals 7, it's like this. If it's x equals 7, it's like this. But if we're talking about functions, we're not going to talk about x equals 7 because this is not a function because it fails that vertical line test. So if we're saying functions, it has to be the y equals guy. Okay, so we're talking about constant functions. So look down at the bottom at 1, 2, and 3. Which one of those is the constant function? 1, 2, or 3? 2. So we're going to write the word constant. Okay, and then let's go back to the top, and I'm going to change the name. Okay, I'm going to change the name. I think identity function is a bad name because that function, you and I both know we call it something else. What do we call this graph? What is this? A blank function. A blank function. I'm changing that word from identity. I think it's wrong, to be honest. I don't like it. And instead we're going to call it a, starts with an L. You're breaking my heart right now. Linear. Whew, my heart. I had to give it to you, so we're not going to give out any points for it. It's a linear function. Okay, Miss Compton, why are you changing the name? Okay, when I hear identity function, I think of the parent function, and as we discussed in our math workshops, a parent function always tends to go through the origin, and you and I can modify that parent function, but calling it the identity function, well, it's not the identity for quadratics. It's not the parent function for absolute value. So I want to change the name to linear, but if you write identity on your paper, I'm not going to count off because that is how it is labeled in the notes. Okay, looking at the bottom, 1, 2, or 3, which one of these is a linear function? Number 3. Arturo, you had a question.
Yeah, for me, I was just going to say, so basically it's just a linear, it's almost like a slope form, but it's just without a y.
Well, the intercept's at 0. That's why it's the identity or the parent function, because the intercept's at 0. Okay, and then we got one last one, and we've kind of hit on it lately, but not exactly how to graph it. So you don't know how to graph it until now. We're going to discuss that today, but we're also going to discuss our graphing calculators. And the last option is absolute value function. So looking at the 3 at the bottom, obviously number 1 is absolute value. Number 1 at the bottom is absolute value. And okay, so it's easy to identify if you're given a graph which of the 3 kinds it is right now. That's it's either straight like this, it's either tilted, it's linear, or it looks like a V and it's absolute value. That part seems pretty easy. The harder part is remembering the graph of the parent function. So if we're discussing parent functions, a constant one, it's just any number that's going to move it up or down. I guess the parent would technically be when it's at the origin. So I guess in my mind, y equals 0 is the parent, the constant parent. If we have to give that, because we like to be creatures of routine, if we have to give everyone a parent, then I guess the constant function parent is the straight line that is the x-axis where y equals 0. And Seth was catching on to this a second ago. What we're going to call the linear parent is just the graph y equals x. Or if we want to write it out in mx plus b, so you and I can really think about it, it's y equals 1x plus 0. Our intercept's at 0. Our slope is easy. It's up 1 over 1, up 1 over 1. You have to agree. That's about the easiest line you could graph, and that's why it's the parent. It goes through the origin, has the simplest slope, it's the parent. And all the other lines that we graph technically come from this parent. Okay, so those 2 I think you could have gotten on your own. The last one is the absolute value function, parent, and we kind of discussed the other day that most parent functions hit what point?
0.
Yes,
Oh.
and your group gets a point. Okay, so most parent functions, you can spot them because they go through the origin. So the absolute value parent is y equals absolute value x. But if we're thinking it through, it goes through the origin. And it kind of reminds me of the linear parent because it does go up 1 over 1, up 2 over 2, up 3 over 3, up 4 over 4. It's just like a linear on the right. But the deal with absolute value is that you can't have any negative numbers. So you used to go down 1 and over 1. Well, you can't do that anymore. And there's no negative value. So if you plugged in negative 1, for x, so let's say you're trying to figure out a point, and you plugged in negative 1 for x, well, you would get y equals positive 1. So your point would be negative 1, 1. So basically, anything that used to be negative and down below that x-axis is now flipped up above the x-axis. And then if that's like Miss Compton, I don't understand that. This is how I always think of it. That was a little deep for me when I was younger, like what? So everything negative flipped positive. And then I was like, but that's negative on the x. yes, it is negative on the x, but nothing's negative on the y. I always did, when I'm graphing the parent, over 1 up 1, both sides, you go over 1 up 1. And then from the next point, you go over 2 up 2, over 2 up 2. And then, can you believe it, over 3 up 3, over 3 up 3, over 4 up 4, over 5 up 5, over 6 up 6. It's a creature of routine. It's very easy to graph. Okay, but the good news is, I do not care in this section. I have a limited number, so I pray some of you have your own. I do not care in this section if you use a graphing calculator to help us figure out some of the things. I do not care. Okay, let's go to the next page. Okay, this next page is a bunch of words. Bunch of words. And we're going to just hit the highlight words that you must know. And then, honestly, we're going to practice it, so it's going to be okay. Okay, so what we're going to do, now that we can identify those 3 parent functions, is we're going to transform them. So we're going to move them left, right, up, down, flip them over, stretch them out, make them skinny. We're going to do a lot of different things to them. So we're going to talk about transformations. And one type of transformation is just a translation, which is just when we move something up, down, left, right. Up, down, left, right. Literally, up, down, left, right. So if I'm the absolute value function and I move left, right, up, down, I am just being translated. A reflection is exactly what it sounds like. So here, let's draw us a little picture. So if I'm the absolute value function, here's my parent. We can graph it just to help us remember what it was supposed to look like. If I'm translated, maybe I moved right and up. So that would be an example of a translation. A reflection is when we're flipped. So this used to be my parent function. Maybe we flip him down, and now he looks like this. That would be an example of a reflection. When you flip it. A reflection is just flipping. So we can move him left, right, up, down. We can flip him over. And then the coolest thing that I think we can do with a graph is that we can do something called a dilation. And that's when we're either going to, and you can have a point for that, that's when you either shrink something or you stretch it. So for instance, this was our original. Maybe we make him super fat, and now he looks like this. Or maybe we make him super skinny, and now he looks like, let me get a different color. Maybe we make him super skinny, and now he looks like this. So a dilation is either when you make somebody really fat, or you make somebody really skinny. You either enlarge it or reduce it.
Can I see the first one?
Yes. Okay. And then they give you a whole box explaining what Ms. Comden just explained in normal English. You know, they put it in mathy terms. So, like, if you add a constant, then this is what happens. If you reflect it, this is what happens. Okay, so, and it's not that it's a bad list. It's just that most of us are never going to learn this list. It is what it is. So we're going to figure it out without referencing this list. But if you ever get confused, there is a chart to help you figure stuff out. You and I, we're too good for that. Okay, we're going to skip number 1 at the bottom because it says describe the transformation. That's tomorrow's problem. We're describing tomorrow. We're going to flip to the next page, 29. We're not going to do 2, 3, 4, 5, 6, 7. We're going to the next graphing one, which is number 1 at the bottom. And we're supposed to graph y equals absolute value x plus 3. Now, using our brain with the x plus 3, do you think that's going to move us up, down, left, or right 3? So you would say right. I would say right. So it's 29 at the bottom. 29 at the bottom. You would say maybe it's right. Well, what's interesting is if stuff's on the outside, like a number's out here, that moves you up or down. If it's positive, it moves you up. If it's negative, it moves you down. But with an absolute value, if the number's on the inside, like plus something or other, it moves you left or right, and it's the opposite of what you think. So Paige said, since plus 3 is on the inside, she thought we would move 3 to the right, and it ends up being the opposite. So instead, we're going to move 3 to the left. But regardless, the coolest thing ever is we've got this graphing calculator. So, do you have one of these?
I do.
Okay. I'm going to stop saying words. If you need to come get one, come get one. You might have to share with your neighbor. Come on. Come get it. It's fine. We'll get it. I have 24. Oh.
I just
I have 20 down before.
I just called 24.
That's nice. You should have been here. Anyone else need a graphing calculator? We're going to show you how to use it in the graphing calculator. Okay. So, come get it. I still got some left. I got 1, 2, 3, 4, 5, 6. And I can pull up a 7th if I need to. Okay. So, I'm already telling you that this is going to be plus 3 move to the left. 1, 2, 3. And it's going to be here. And again, we already understand that it's up 1 over 1.
Where's that? 3?
Yep, 3 to the left. And I already know it's going to look like this. Because I've taught math for a while. And I know plus 3 goes the opposite way. And I know with an absolute value, you count over 1 up 1, over 2 up 2. And the same thing on the other side. Over 1 up 1, over 2 up 2, over 3 up 3. And it ends up making this lovely V. It ends up making this lovely V. So I know in my head, because it's plus 3, that instead it's going to move my parent function, which was just normal V at 0, 0. It's going to move it left 3. And then after that, I graph it just like we graphed the other parent function. Over 1 up 1, over 2 up 2, over 3 up 3, over 1 up 1, over 2 up 2, over 3 up 3. And if you understand that, my God, you don't need a graphing calculator. You can probably do all these in your head. But if you don't, if you're lost, then here is my suggestion. So we can graph it and make our calculator help us. To do that, we've got to be able to tell it to do absolute value. So let me turn on my light. So we need to
How did you get to that?
press y equals. So if we're on our main screen, you have to press y equals so we can graph. Okay, so we're going to graph absolute value. And I don't see those bars anywhere down there on my options. So what you have to do is you either can, I don't know how good you are with your calculator, you can either press alpha and type ABS, because ABS is for absolute value, or if you're like me and that's not going to happen, you can press math. Is it math? Yes, it's math. So you can press, you're in y equals, you press the word math, you have to scroll over to NUM, and I see it at the very top of my list, ABS parentheses. ABS parentheses. So let me say that again. You're on the screen, you press math and then number and then ABS parentheses and you press enter. And look, it's done the bars for me. But if you understand how to do the green button alpha and you type the letters ABS, it's going to understand you're meaning absolute value anyway. It's a smart calculator. Okay, so you and I were trying to graph x minus 4, so we're going to, or x plus 3, so we're going to type in x plus 3. X is the button that says X, T, theta, N. Press X. So I press X, and then plus, and then 3, and now I press enter. Okay, so let's go over it again. I did second y equals. I did not do second y equals. Must come in. I did y equals. I pressed math. I scrolled over to NUM to get to absolute value. I pressed enter. And then I needed to type x plus 3. So the letter X has a bunch of other stuff with it. It's like X, T, theta, N, but that's the button for X. Then plus, then 3, and now I'm going to press enter. And enter does nothing. You're like, but Miss Compton, we wanted to make a graph. You're right. So we need to press the graph button. So everybody hit the graph button.
That's dope.
It is at the top. It's the very top right button. Very top right button. Okay. I don't know how your calculator's set. I don't know how your calculator's set. So if your calculator does not look like mine on the screen, someone's messed with your settings. Your zoom is wrong. So let's change your zoom. You need to press, if yours looks weird, mine doesn't, but if yours looks weird, you need to press the word zoom. And then it's best to normally go with Zoom Standard, so it's number 6. So basically yours has been Zoom Weird. Bless your heart, the stats kids use it. So you press Zoom Standard to make it go back to normal.
How do you remove
How do you remove what?
the line from the graph?
If you don't want this graph anymore, you're moving on to another problem, and you don't want to see that bad boy anymore, you go back to y equals, and you just clear him out or delete him. But otherwise, he's going to be in your calculator from then on out. So it would be smart of us. Yes, dear. Bring it here. Okay, it would be smart of us, since we're trying to figure out what happened to that parent function, it would be smart of us if we, because you have something weird, look. Okay, let me show you what happened to Paige. She has something typed on Y4, so hers wouldn't graph. You've got to make sure everybody below has nothing going on, so when you press graph, it actually does graph. Okay, so it would be smart of us at this point to realize, but the whole point of this is to see what happened to that parent function. So maybe we should graph that parent function too. So you can graph two things at once. If you go to Y2, you could press math, go back to number, ABS, and just type in X by himself, because the parent function was just X. No numbers, no nothing, just absolute value X. And then if you graph that, you would have both the parent and the transformation. And then Kelsey could say, well, duh, they picked it up and moved it left 3. Which is all we're going to talk about tomorrow, is how did they move it. So if she understands how I did that, that would probably simplify her whole life. So again, your calculator can graph multiple things. So when you press Y equals, it might be smart to put that parent function on Y2. That way when you press graph, you can actually see both of them at once. Okay. But again, if Hal understood how I graphed it before I referenced my calculator, then he really doesn't have to do it in his calculator. Eventually there'll be harder stuff in life, and he'll be glad he's learned the calculator buttons. But until then, if he understood plus 3 meant left 3 with that parent and it stayed on the x-axis, he's good to go. Okay, so, and if you, like Gracie said, what if you want to clear them out, or someone did? Then if you go back to Y1, maybe I don't want to see that parent, so maybe I'll clear him out, and I'll only have my moved graph again, because maybe both of them at once are confusing you. Maybe you only need one at a time. Okay, but again, we need to, that graph is hitting at 3, and I need to put that down here. So, if you're not sure, you're like, I think that graph's hitting at 3, but that's hard to read, your calculator is flipping amazing. So you can, on your screen, scroll over and see. Or even cooler than that, there's this button called Trace that helps you be super accurate. It's the button right next to Graph. So if you press the button Trace, which is right next to Graph, it can help you figure out all the points. So you could be like, is that really 3? I don't know. And it would tell you, yep, it's negative 3, 0. Or if you press Trace and then say, what is it at negative 3? Oh, it's negative 3, 0. Your calculator is a very smart thing. It could probably answer all your life questions and do all your math for you if you just knew how to ask it nicely. Okay, so did you press Trace and then type in negative 3 at the bottom? Because if you ask it, like, hey, is that really negative 3, question mark? It'll tell you, yep, negative 3, 0 is that point. Because otherwise it's like negative 2.97 something, 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 and maybe you're smart enough to realize that's really negative 3, but your calculator's too fancy for us in some ways. So you might want to ask it directly, like, is that negative 3? I pressed Trace and then negative 3. So I asked it, like, when I press Trace, I'm asking it, what really is that value there? And it tells me, yep, negative 3, 0. So I know I graphed it correctly on my paper. That's the moral of that story.
Hey, when I did number 3 on the calculator, it said error.
Number 3?
Yeah.
Okay, did you...
I did it just like it told me to.
Okay, show me what you typed on your screen and I can help you. Okay, let's go to the next page, because we got to graph some more. Again, I'm pretty smart, and so are you. I see absolute value x minus 4. I already realized how is that going to move my parent function. And Eduardo, that's how you got a point. I already realized that minus 4 on the outside means I'm going to move down 4. 1, 2, 3, 4. And so I know I'm going to go up 1 over 1. It's the same thing. I know this. And so if you get that, you can go ahead and do it and have this lovely V on your paper. Terrific. Good for you. Otherwise, the rest of us are going to literally type it in our calculator. But what is the important part when you type this one in your calculator? And your book group gets another point. You better make sure that -4 is outside your absolute value bars. So if Patrick's going to type this in his calculator, when he types in absolute value x, he better not put -4 inside. That's not what the problem looked like anyway. He doesn't need to do that. He better put -4 on the outside and then press graph. And lo and behold, yes, it did move down 4. Any questions about number 2? We're flying now, baby. Number 3, what do we assume happens to it? Is that negative on the outside?
It's a, what's it called? What's that function?
It's gonna,
Space right.
it starts with an R and F, either one. That negative on the outside, what's it gonna do to me? It's gonna,
Reflect.
thank you, Hal, I saw your hands, you can have the point. It's gonna flip you. I was positive, I'm going negative. So I wasn't a happy V, and now I'm going to a sad V. So literally, I'm still going to be at the origin, and I'm just going to be sad. But if Gracie wants to graph this on her calculator, she goes to y equals, she types in -x, but God bless you, and I know you don't know how to use the calculator, and life is hard. You better, when you use the negative sign, use that bottom negative sign right here. Not the minus sign, the negative sign. If you use the minus sign, I'm not promising it's going to graph for you. You've got to use that negative sign. But again, if Hal's understanding all the transformations without graphing on his calculator, don't graph on your calculator. Or graph just to check yourself. Okay, so we did negative, math, number, absolute, x. We press graph, lo and behold, yep, just like Ms. Compton said, it flipped down. Okay, so number 4, it's got a -2 and a +3. What do we think is going to happen to it? -2 + 3. What's going to happen to my parent? It's got 2 things happening to it. It moves how much up, how much left, what's going on? Or how much right, what's going on? It's going up 3. And that -2 is telling us to go left or right. It's the opposite of what you think. You would think minus would be left, but minus is right. So it's going to be right 2. If I can spell that, it'll be right 2. So if you realize that, okay, I take what was the V, it was at the origin. I go right 2, 1, 2, up 3, 1, 2, 3. There's my new guy. I went right 2, because you said right 2, I went right 2. You said up 3, I went up 3, and now I'm drawing my V here. V! Yay! But if you said, to me on that, again, you got that lovely thing in your hands. You don't need that negative sign anymore. X -2 +3. Press graph. Oh my goodness, it did it for you. If you want to make sure that you know what that point is, press trace and figure it out. Say it again, Paige. Did you, when you typed in your calculator, go to y equals, did you use the, show me what you typed in? Okay, you probably typed in the wrong thing. Did you put x -2 + 3? Are you sure? Okay. Again, half the thing of getting the calculator to cooperate with you is did you type it in right? Okay, let's flip to the next page real fast. Real fast. You're not going to have to do any homework tonight. Can't you just tell if you just keep going, I'm not going to make you do any homework tonight? Are you serious? Okay. Number 5, 6, and 7 is all you're going to have to do. That's all I need done by tomorrow. That's all I need done by tomorrow. 5, 6, and 7. 6 and 7, you're going to learn a miracle, and if you're listening now, I'll tell you the miracle. You would think y = 3 would make me super duper skinny. Instead, it makes me super duper fat. Or does it make me skinny? I don't know. Which one does it do? But you can figure it out with your calculator. 3, math. Oh, wait. It does make me super skinny. So my way of remembering who's going to make me skinny and who's going to make me fat, it's a really easy thing. And maybe you'll hear it now and maybe I'll say it again tomorrow. My note to myself about with dilations is that fractions make you fat. if you have a fraction out front, your graph's going to be really fat. If you have a whole number, your graph's really skinny. Okay. I would love for you to try 5, 6, and 7. You have 4 minutes. You feasibly could get this done. But you also know I need my calculators up. I need my life right. I need all the things from you all the time. Does anyone need help with their graphing calculator like she does? I would love to help you.
So what I'm doing, how do
Okay, so you're on one equals. You press math.
and then scroll up in minutes and look there.
On that thing, you see that it says it's got a round thing and then the pause button and then a stop on the screen on my computer. It is. Put it on my desk.
It says what?
Yes. You press the stop button. It's that one. Nope. One next to the right of it. That one.